It hasn't
No,
happened yet.
not as far as here, but
Okay.
it's hot. So we
It's
cannot wait for
yesterday.
the weekend to go to the mountain and hike in the mountain. That's what basically. Uh,
Nice. Yeah, yesterday we had the Boston. It was hazy and hot and humid, but it was also weird and colorful, like orangish, and it was kind of a weird experience. I took a picture of the sun. It was like this
mm,
bright orange thing. So I don't know. I mean, it's probably New York is experiencing that, but at least that bloom is kind of gone. Anyways, I think we can get started. So let me just share my screen and make a few welcome remarks and we can get going. So welcome everyone. This is the QuantUniversity summer school, as we call it. We have started this whole tradition of having classes in the spring and the summer schedule. And this year, we had a lot of discussion on generative AI and agentic AI, and Agus and many model risk professionals from different parts of the country. We all joined together a few months back and we had a round table. It was a fantastic discussion, and one of the key themes of that whole discussion was this notion of, well, there is this gap of awareness of what should be done. And then we have 26.2, which dropped on us, and there was a carve out for agentic AI and generative AI. So we are on this mission of kind of bringing all the practitioners together to see how can we gravitate towards a common understanding of what's actually out there and what is relevant for the financial services businesses, and how should we think about addressing the various capabilities as we see today and also the associated risks. And in that front, there has been a lot of work going on both on the technology side of things. On the risk side of things, there are very few formal frameworks, and that's where we are trying to see how best we can leverage the knowledge we already have with SR 11.7 and the various regulators putting out position papers and call for information and request for information and things like that. And we are hosting a 4-week workshop. So we just completed the first cohort last week, and we had people from FINRA, from Fannie Mae, from PNC, from USA, from FHLB Boston, a lot of people from senior professionals in the model risk space, and they joined the discussion. And with popular demand, we are doing a second cohort starting next Tuesday. I'm going to be posting the links if you're interested in joining. So this basically is something, as a course I've created, but I'm also collaborating with a lot of professionals, both who are practitioners, but also who are kind of building the frameworks. And I would highly encourage you to see if you would be wanting to be a part of this network. And one of the goals is to bring in like-minded thinkers to formally kind of think about how we can build this whole profession on generative AI risk management. In that realm, Agus and I, we keep talking on a regular basis, and Agus is a dear friend. He has kind of contributed so much to the QuantUniversity community. He every time I ask him, what is he working on, he shares a 600 and 700 or 700-page document on all the work he has been doing over the last few weeks. And with generative AI and many of the DGX Spark stations he is running in his station, he has all the right to complain that it is hot, despite what's happening outside of his home. But in all seriousness, Agus is probably one of the few thinkers who don't just kind of work in the space of particle physics and equations. He's grounded to what's actually needed in the industry. Because of his position at Wells Fargo, so he was influential in putting out so much research, contributing so much to the open access and open source community, and also building out different frameworks for addressing various aspects on the traditional machine learning side of things. And now that he's a free bird, I don't know what free means, maybe he can go for a hike and that's what his freedom is, but he spends the rest of the 23 hours working on different frameworks, and Agentic AI is something he's been working on very diligently. And he shared some of the work he had been doing in the last few weeks and thought we'll bring Agus back as a guest lecturer as a part of this course to kind of address some of the things he's been doing. So it's a 2-part workshop. So this session Agus is going to be talking about the prompt and pray, which he's kind of evangelizing as a part of the whole notion of how do we think about generative AI. And he's going to talk about some of the frameworks he's been building and the applications, and he'll also give you access to some of the white papers and code he has been working on so that you can practice it. And in a few weeks, he's going to come down and talk about how do we address it from a risk perspective. So today, this workshop, we'll try to keep it around 60 to 75 minutes to get you the overview, and we will save the last 10 to 15 minutes for Q&A. And if you have any questions, please post them in the chat window, and I'll try to bring them up consolidated at the end. And as usual, this series of sessions is happening because of you, because you practitioners are taking time off your busy schedules and joining in. Any feedback, any engagement, any kind of notes you can send me over LinkedIn or direct messaging. I would love to involve you as a part of the community to ensure that we grow this whole profession and ensure that the rigor and the robustness which we have built as a profession can be kept and also grown as we see new challenges and technologies come into the purview. So with that, Agus, I will hand over the stage to you. Welcome again.
Thank you. I will share a few screen and to start, because all the materials that I am going to use are available to you, including the software, free software that you can use to learn or to use it. So let me share a little bit. So hang on 1 second. Hopefully you can see my screen. I want to say a little bit because my collaboration
Agus,
with
the
friends.
microphone is a little garbled. I don't know if an adjustment needs to be done or it's on my
Is
end.
the microphone
Yeah.
really not good?
There was a little bit of garbling in the way the thing was coming through. So just we'll see it for a few more minutes and see if
Okay,
there's something.
let me see if it can be better. Let's try. Let me know. Okay, so Sri interrupt me. So I would like to thanks my collaborators, the team from Knowledge. They have been working with me closely on this subject. They make the software available, publicly available for you, something that you can download. So I would recommend you to visit the Knowledge website, and then you can download, you can install the free software, available software. You need to create your own access key, okay, but it's free, okay. So because they just want to know who are the user, so they track it with that. So so you can install it from PyPy, the ForgeLoop, the test loop, the proof loop, and the ForgeLoop, the software that we're going to use a little bit in here. Those are free to use software. You just have to get the key from the Analytics. Also, all my talk today, it's available from the website that you can see here. I think Sri shared this. If you click on this, it should open your browser to the presentation, basically. So this is the presentation deck that I'm going to use. Then I am going to do one more things. It has a book called Beyond Prom and Pray by Knowledge, which has all the chapter that I'm going to talk about. It has all the chapter how to do in very detail. And then at the end, it has capstone project. This is the capstone project that I'm going to use today. This is basically building a complaint handling. We'll talk about it a little bit. Complaint in a banking world. Okay, so the example is really how to, this is an education, of course, and it's an educational material, so you have to simplify it so that it has the educational value, but I think it's detailed enough and complete enough. And then has the testing component, how to test agent. There is a sister book of this. It's called Beyond Ship and Pray. For some of you that are interested in, that's really dedicated for validation and testing. But we're going to touch it here a little bit. But there is a book on this, and each chapter has Jupyter notebook that you can exercise yourself to do that. I don't know if I have it here. I think I do. Let's see. It should have a notebook that all the chapter. You see all the chapter. A few example in one chapter that you can follow. It's a Jupyter notebook. The code is open source, so you can see the source code in Python. So nothing hidden. So you can see everything. Uh, if you use code agent, you can ask your code agent to read it, to explain it to you. So everything are in there. Okay, so I am very thankful to the Knowledge team, the collaborator in Knowledge for the generosity to work with me on this fun project and make the code publicly available as open source. Okay, so you have open source, you have the book, you have the notebook exercise for each chapter in the book. So if you want to have access to the book, so they can send you a copy, electronic copy of the book, go to the contacts and send email to this, or send email to the knowledge people. They will send you free copy of the book. Basically, you register it, and you send message. They will send you free copy of the books. Okay, so the software is free to use. It's open source. The books are available. Everything for you to do. So I hope that's very clear to start with that. And with that, I am going to talk about the beyond prom and pray. And so I and what is this different? We'll talk about the problem of prom and pray, uh, and what that means. I'm going to talk about that a little bit, and why they are not reliable, and this whole methodology that we're going to discuss, how to make Gen AI becoming something that we are very confident to use. And agentic system, how to build agentic system so that we can rely on. So that's the key. We're going to talk about the methodology, pillar, and then the methodology. You will see it here that I am a component of for specific application for corporate for industrial application specific application. What we need is small fine-tune model. The tool that you download have all the things that needed to do the automated data generation, to fine-tune your model for your specific domain. We'll talk about that part of the workshop. We're going to learn GMS, geometric memory system, and we're going to see what it is and why do we really need it to really complement your LLM. And then, of course, the how to do the data generation for automated testing or for fine-tune your model using design of experiment, which the tool is also in the is part of the package. We're going to do a capstone project, a governed banking complaint agent. So we're going to have an agent to handle complaint. We'll talk about it a little bit. I probably will fast forward a little bit on that and how we build it on this, and then the build, how we build it, and then the companion volume. There are two other books that you may want to be interested in, and that book has all the same. We have the same structure, similar structure with all the Jupyter notebook and code and everything. Ship and Pray is for testing. chunk and pray is for retrieval, is your RAGs type system, right? So that's the traditional RAG with dense embedding. I call it chunk and pray. Okay, so how to do it? So that's what. So three parts, and that basically the application of the code, the software is all open source, and the with all the companion. So with that, let's get started. So this is what we typically do today in Agentic. A system prompt can be very elaborate prompt that control your agent or control your Gen AI, and a flat memory and factor store to remember as a memory, store in .md or store it in the rec style with chunking and then factor database to store, which I still call it flat file. Okay. And then we have a second model to do the judging. This is your LLM-as-judge, right? So that's how we do it today. You control your agent with prompt, you store it in your .md flat file or some variation of that, including factor database, and then you do the LLM-as-judge. And so what's the problem? It's one on the control, we control it using prompt. Prompt tell the system what to do and what not to do. And works okay as a demo. Okay, the memory, I talk about the flat file, uh, the history of the information, the context, and all those things in there. Okay, then LLM is just. So, but I would argue this, yeah, to make it reliable. The reliability is built outside the model. The model is just the smallest part. You get from in, you get text out. That's your model. The the system that make it work. This is on the agentic side. It's the loop. It has perceive, decide, and act. Right? It leads it to reasoning and decisioning, and execute something, and then evaluate. Right? So so that's the loop. That the common loops that people do. But what's important is really gate stack. Okay, that every execution, every process has to be evaluated on the input, executed the process, check the execution, evaluated the output, and say yes or no, good or not, go or no go. Right? That's what we do. Now, it's important on the decision on the evaluator that we talk about it later. It need to be something that we can rely on. So we talk about the budget, how much computing and times of execution, the memory, we're going to talk about it, the structure memory, because that's a very, very fundamental. Tool registry, the tool need to be registered so you can see how the tool gets executed, the history, the input of the tool, the output, so because that's the execution and the audit log. So that's the things that happening outside the model is really the key that make it work. So if you think about it, the whole system of agentic model is a small part. The outside, the control outside is really what's important. People call it harness. Some people call it something else. But here's the thing: the prompt and pray model choice, and what we are going to do different. The difficult thing is, okay, we control only through instruction paragraph. We control it through context. We control it through prompt. And run with behind, hosted behind API, your ChatGPT, your Cloud Code, your Gemini, and all of those things running everything. The decisions are opaque. You cannot inspect what the things are done. It's give you answer. And it's difficult to reproduce. You run it twice, you run it 3 times, you get different answer. And then you say is the answer good or not. You judge it using that model too. So everything is one gigantic pile, using just relying on single model, big model, everything controlling the input and output, the evaluation, the reasoning, even your your audit log. What is the output? It's based on the model. So we have very problematic here, because how do you trust it and how do you control it? So that's one process of prompt and pray, that relying on the flat file.md, relying on the LLM as a LLM as reasoner and LLM-as-judge. Now we're going to make a sharp turn today in our discussion. We're going to use several small model and fine tune. In fact, in this example that I'm going to do, I am going to use very small model. I'm going to use QN3 4 billion parameter model that you can run in your laptop, right? Because we use models for such a narrow job, run locally, and very controlled, and we're going to and you will see it later, using the right system outside the model. It can do an incredible stuff. Okay, the reliable part are the loop, the gates, the memory, audit chains. Okay, you can see that model are small part of the entire system. That's what agentic is, basically, right? So that's what we're going to focus on, really on the right hand side, how we can control it step by step, so we can come up with system that is very transparent, system that we can trust. So we're going to replace this one, okay? System prompt. Okay, do system prompt it's instruction to enforce boundary, to do and not to do. We're going to replace that with calibrated admissibility gate. Okay, very rigid to check whether this is uh, the instruct process, and check the process, and report the output, not and check based on the verification, and not only based on what the LLM produce, right? The flat memory that we talk about, we're going to replace it with structured store, very structured information. And this is, we're going to use knowledge graph for this. This is where we're going to learn geometric memory system, building memory that is very structured. Let me say this one to make it a little bit more something that you can relate. When you read a book, you don't memorize page by page. What we memorize is the concept. What are the critical concept? What are the important concept in that book, in the paper that we read, and we store it in our brain as an understanding, logical understanding, not just I store it page by page. But your LLM, your current approach, people don't do that. Most of the people do store it. If you use Anthropic, LLM, Claude, and all of those, you created a lot of .md storing in the in page. No structure in there, right? It's unstructured text. So we're going to learn today how to store it as structured text. It has a logical capture. The judgment we talk about is using second model or using the same model to evaluate, to approve or not approve. We are going to use an independent, a non-LLM verifier that can understand quite exact number, is reproducible. You can trust and you can replay, it will get the same answer all the time, right? So it's very important in this concept of this is what distinguishes between prompt and pray on the left, and what we're going to do on the right. So it's going to be gated, information produced will be gated, will be calibrated. So we're going to look at it. Memory will be stored in a very structured way, and then we have an independent non-LLM, outside LLM to check. So that's the entire things that we're going to do today. Okay, so this is an example. So we're going to run the capstone project using the using for this. Let me maybe flip quickly fast forward quickly. We're going to go back to this, okay, so that you understand what the project that we're dealing with. Okay, going to have we have customer message that can be complain or not complain. It will run into Git stack to check based on that. Hey, is there any PII or any prompt injection on this? Because people can write the message saying ignore any policy that applicable to this or ignore such and such. Answer me on this one, right? So that injection is happen all the time, right? It's like people that submitting paper to new reps, they do prompt injection in the text because they know the paper will be reviewed by AI, right? So they put injection so that the paper gets approved and less criticized, right? So in customer message, it will have a lot of injection as well, part of that, right? So we'll have all this. First is the uh, gating system to check, hey, any PII escalate, cannot go, right? Any prohibited advice or something, an injection, and all of those things. So you have things to do this, right? And then you from that message after passing that, because if it has some of the prohibitive stuff, it will be refused, get escalated to human, right? If it's not, then it go to classify, hey, is this complaint or not complaint? When it's complaint, we're going to extract the fact and check inserts in the policy. What policy in the system are applicable? If you complain about, let's say, fees and unfair fees or something, then you have Reg E that's applicable, right? So search in the policy or the policy or what is the refund that can be handled, and all of those is in your policy, right? So search policy, some of the thing in the policy, if it has regulative flag associated, Reg E, Reg X, or other reg that you have to flag, then you get flagged, right? And then draft the response, right? Draft the response and drafting the response to the customer. And then, okay, then it has some requirements, some does respond, make sure that its response is safe and all those things. So it has gated and escalate, or if not, go straight, right? So this is the, the, the project that we're going to use throughout to illustrate the process. So how do you do this one? And if I do prompt and pray, the whole thing will be handled by one model, right? And I control, hey, now check if it says PII or something. You give a prompt to your model to do that, right? And then, hey, is this complain or not complain? The same model will do it, okay, through prompt instruction. Then you extract, hey, is this something that I have to care about because it has regulatory impact, it has policy, it has search, any policy that applicable, find it, okay, search, right? You ask the same model doing it. And then anything flagged to a certain regulatory, that model will make decision too and draft the response of that. So you can do this whole thing using prompt, using elaborate prompt, and send it to ChatGPT or send it to Claude, right? Do that by throwing to elaborate prompt, right? So that's what people do. That's what I call it, prompt and pray, you get prompt, you specify with prompt, whatever elaborate on that, and then you use your LLM also to judge it whether it's correct or incorrect. And you pray, hopefully it's correct. Then you check. Then you have human checking every single one of them, right? The human checking the final output, human check it. Well, there's a problem in that because you check the human output here, but you see the agent is running all kind of steps that people can it's a mismatch there in terms of speed, in terms of things that this machine can look at compared to what people read only the final output. This is why I don't believe in human in the loop. Human need to be over the loop through escalation. The machine need to give information, what's happening. So at the bottom of here, it has audit log that really audit log every step, right? So we know what's happening in every step, the input, decision, the structure. So we're going to go through that in some example of that. Okay, so we're going to do it not through prompt and pray, but we are going to look at it one by one. For example, in here we have a fine-tuned model to make decision whether we have prompt injection or not, right? So you have a classifier. So we build a classifier, not just throw it to a language model, but we do classify because it's a classification problem. Is it prompt injection or not prompt injection? How do we know? So we if we build classifier, we know the capability of this classifier, and we can design it because we can train it with specific data. Okay. Complaint or no complaint is the same thing. So here we're going to fine-tune model to say complaint or not complaint. In this case, I am fine-tuning QN, okay, using LoRa, a small model that will do that. So I'm going to go back because I tried both sides. Yeah. So I run it with prom and pray, right? I run it using the most capable frontier model here. Yeah, I run it using Opus 4.8, right? Claude Opus 4.8. The groundedness is correct 75% of the time. This, if you do the fine tune on this, 100%. Right? The interesting piece is this. The interesting piece is this is because we say, okay, we're drafting the script here at the very end, right? Drafting the script. Then the script is grounded. It's 100%, no hallucination, right? So because we control it, we fine tune the model. And this is using general purpose model, using Claude. And then I ask Claude to say, now judge it. How good is the answer? You see the fluency answer, I asked to rate it 1 to 5. Opus rate the answer of the trained model low, 2.92. Rate itself 4.25. Why? Because language model like verbosity. If your answer is verbose, written in very fluent language, long, fluent language, even though hallucinating, it's going to get very high ranking. This fine-tuned model, it was fine-tuned purposefully so that the answer is very, very strict. Follow the policy and strict and brief and not using fluffy language. It's not promising something that you should not promise, right? Concise, the answer is concise, is clear, is controlled. Language model rated low because of the conciseness, because it's strict. It cannot do a language that is fluffy. So you have to be very, very careful when you use language model as a judge because it judges based on fluency. So that's I thought this interesting fact here. I tested on the drafting response, and the answer was very, very entertaining. You see, the original model, no fine tune, is even score higher because the original model have more fluff. This model is trained to be strict. It's rated lower by your judge, by Opus. All right. So this I thought is interesting uh, to see this one and give us motivation on why we do what we do. Okay. So one of the things that we want to do, because we talk about memory, we talk about logic. Uh, this is the key thing is to really capture the uh, the the corporate knowledge, your policy, your regulation, and how that's begun into memory and capture it in a in and in a very logical way. All the from unstructured text into structured text. So this what I'll give a just very brief about knowledge graph here, and I'll give a few example a little bit later. It's really basically, hey, I have a complaint, and this is very simple things. Then we can going to convert it into something that's structured. So in here, in knowledge graph, we represent everything into what we call a triplet: head, relationship, tail, subject, predicate, object. So we represent everything into triple. So if you have a long document, it's going to be parsed to create all these triplets. So you have all this very strict representation, logical representation, right? So that's what the foundation of the knowledge graph. We're going to use this one because the decision making check to verification, converting from unstructured memory into structured memory, everything will be done through knowledge graph. I'll do illustration a little bit on this a little bit later. And on top of this knowledge graph, we're putting a computation system so that we can measure. That's what geometric memory system is. Geometric memory system is built on top of knowledge graph. So that in knowledge graph, if we have had relationship tail as fact, it will be exact yes or no. But world is a lot of things is outside your knowledge graph. So your system has to be able to create plausibility. Is it plausible? So it has the computation plausibility. Missing and tail, for example, it then has to do prediction because this is in rule based or on get. Here is going to be doing link prediction. Is it any conflict? Uh, Fact or conflict. That's we can measure it using tension energy. We talk about multi-hopping, okay, because you see here example of two hop dispute, overdraft, and then governed by overdraft policy. So you do two hop, right? So that's called multi-hopping. And then they complain, and we'll see it later in the example. It can be some hopping that you have to do to draw a conclusion, right? And language model is not very good at doing multi-hopping, and this is where knowledge graph and logic are very useful because it can do multi-hopping to draw conclusion in very consistent way. We're going to do exact number, so it has to be because we're dealing with number $35 is $35, $35 and $36 are different, $35 and 35.5 are different. So we need to have a look up exact registration, and then you have to do when we get answer. We need to have how confident the answer is. That's the calibration process that we have. So that's why we need to put we need to put math on top of this. If some of you that interested in this more detail, every week, every Saturday, I publish an article in Substack with tutorial on on top of knowledge graph. That's the knowledge graph embedding and operation on knowledge graph. So follow my Substack, my Saturday Substack. That's to learn about the methodology more detail. I always post it with code, etc. My my Wednesday post is more on the data science, on the machine learning. My Saturday post is on the knowledge graph. So that's if you haven't followed my Substack, follow my Substack. So what we do then is from document, plan policy, manual, whatever that will become the truth. Yeah, your policy become truth. We're going to convert it into knowledge, into code, right? Extract it. We extract it. into triples, triplet that we talk about, into exact numerical entity. We train the system, okay, so that it can do computation. So this is training the system on the knowledge graph, and then do calibration so it can make decision. Is it plausible? Is not plausible, etc. Let me do an example of this instead of making it abstract. I think I have example here that is very simple. And this is part of the package that you can do. So we have a source document that is very, very simple. There's a reading document. Hey, I have you can see this one in my Substack as well. Yeah, the person relationship. Okay, Anne married with Bob, Carol with Eve, then parenthood, parents is Anne, is parents of Carol, and all of this relationship, right? So person, sibling. So first is, okay, I have this one, or any document, you can parse it, okay, to become something. For this purpose, I just show it very, very, very simple. Uh, and you can do a knowledge graph, extract it, and then extract the, hey, it has 9 entities, 9 people, okay? It has 4 relationship, okay? And create 18 triples, okay? Create 18 triplets. You train it. This is a part of training, loss, and all those things. Once you have it, then you get, okay, here it is. This is the triplet that get extracted, and I'm going to visualize it, right? From the training, okay, after you train it, it found an embedding. I draw it in 3D so that I can visualize it, but embedding is in higher dimension, right? I just use this here to display it in 3D. So you can see the relationship among all those entities, and you can see in here Anne has spouse of Eve, right? So that relationship you can see it, okay? And, and all of those things this is what I drew, how this is the process of learning. It's just in high dimension instead of in 3 dimension, and all operation are really from to bring from head to tail is through in here to rotation operation. Okay, and you can learn the rotation operation in more detail in this Saturday. Last Saturday I posted about the general operation process using matrix, and that's what the system need to learn, right? Then you can see the many to many who's the parent of Frank. You can ask, once you have the system, you can ask, what is the parent of Frank? Carol and Eve. Who's the grandparent of Anne and Bob? So you have all those examples. Then you calibrate with the decision gate so that you can query it. Once you do the decision gate, you can query it. And parents of Carol. Okay, yes, the answer is plausible. Okay, because it says it's mesh calculating the distance from the distance. And parent of Frank, the distance is rejected. No, and it's not parents of Frank. You can check if it's contradiction in here. Is and parents of Carol is okay. Okay, and then you flip it. Carol is parent of Anne. No, it's contradiction. So you can do all this algebraic operation because of that, right? And this is very important. Why is it important? Because we are going to make this. We talk about the decision, the verifier outside LLM. If you recall, hang on one second. If you recall that we talk about an independent non-LLM verifier. That's what that system is used for. And so you can check whether it's correct or incorrect using that system. Okay, so you ingest and then it say, okay, is this complaint uh, 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 violate reg E or not? You can say yes or no, okay, because you can check it. It is a system, okay. And then when you say we drafted the language model drafting a response, we want to check whether the response writes something that should not be written. Because it's promising writing something that you should not. Okay, that can be checked. Okay, check using this verifier. And because you have the verifier that's logic like that, capturing your logic, it's very, very transparent. When you make decision to say it's a complaint or not complaint, approve or not approve, it's very, very clear because it has logic. So LLM can propose, but the decision will always be done by the verifier that is coming from geometric memory system that we talk about. So it's a very, very transparent decision. It's very repeatable. You run it 100 times, it will be the same answer because of that. And it's very fast because it's just matrix multiplication. So that's what it is. So I show you as well capturing a structure store. That knowledge graph is the structure store. Okay. So I need to move a bit quicker here. So that's the process of building that I showed you before. That's the process of building, converting from any document into logic store. Yeah, that's the process that I demonstrated you, very simple. Then you can have a graph grounded retrieval. If we do, if I in this part of this application, we search for policy, right? We have complaint. Is there any policy that related to this complaint? So we gave input is the complaint, customer complaint, and search policy that applicable. So that's typically is kind of rack system that you do, right? So you do dense rack of system, chunk chunk you chunk your you chunk your policy and all those things, and then to factor search to find it and find evidence and all of those, right? So that's your top K rack. If it's GMS based retrieval, we don't do that. uh, we have the query, we search in the query, find exactly the answer. So that's the difference between just simply we can if you're interested in we can next time Sri we can talk more detail about the chunk and pray. So this whole thing is covered in a lot more detail in chunk and pray. So one of the things that we can use with the GMS store. Now we have the store. We store them in that. What can we do? Well, we can do it for many different things. One is we can use it to generate text for fine tuning. Yeah, I can if I want to do fine tuning a uh, 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 a system to be able to do things. I have the truth. I have GMS. I have the truth. That's the answer. I can generate all kind of query based on that. The answer is that what you have in your knowledge graph. And generating that can be done in manual way or can be done in automated way in the system in the ship and pray. It has design of experiment that the with the 40 factors and 12 base factor and then 40 variation that you can apply. It automatically generate all kind of query and the answer you have pair of query and answer. You can use it to fine tune model to do certain purpose. In fact, that's what I did. I'll show you a little later if we have time to do a complaint classification, for example, right? To to do complaint classification and all of those things. You can do it for that. The other thing that you can do, we can generate it for testing because we know the truth. We can generate all kind of scenario. We test it, and then we have the ground truth automatically. So we use this ground truth and pair of ground truth and query that we can use for testing the entire system. So that's one use of the GMS. If some of you in model validation, you can use it as automated model validation because it can generate all the ground truth and all the query. You run your system to do that, and then you can attribute the failure in what condition your system fail and all of those things. That's the subject of the Sri talk about the next lecture in August. That's where we're going to spend time on that beyond ship and pray. Really focus on the testing, how to build the system for testing. Okay. On the complaint handling task, we talked about before. So we have customer message, we look at the policy, we draft response or escalation to human. So we're going to see a few example on that, and we'll go through that. We'll go through that process. Okay. Here is an example, right? Before we go, a work prompt and pray does, and you can have a silent failure because of that. For example, I have case 001, which is customer complaint. I just keep it very simple. An overdraft customer want to remove. It has a, I think I have the complaint language somewhere. When we go to the notebook, you will see it. So then you can, okay, jump rate, friendly, free reversal, quoting figure, impact tax, you may fail. Okay, so there can be some silent failure that can be dangerous. This is why you need people to read, right, as an inspector. But if you do it using very like what we talk about, you don't put human in the loop, you put human over the loop because everything are measurable through the GMS verification. We talk about this. Let's go through uh, the, the process, right? So uh, I share you before. Let's say one example. Okay, uh, unfair fee. We'll go through that example a little bit, and we can see why don't we go to that example so to make it really more real. Let's see. Okay, so this is the notebook on the capstone project notebook, and I show it running end to end. Basically, it has 5 tools here: complaint classification. It has extraction, fact extraction, search and policy, flag regulatory, draft response. These are the tools that call. But when you put harness, you want to make sure, and you will see it a little bit later, that every step will be checked. The input will be checked, the execution will be checked and verified. So all the process, every step, every call will be checked. So you don't just call and get the output, right? So and that's what we that's what we do. Check every single step. Uh, in this example, we have I show you before in terms of the knowledge graph. It has 81 entity, 100. It has 17 relationship, 116 triple. So we keep it small here so that you guys can run it and see the example. Then you can how do I close my checking account? That's an example done, and then you have final classification. It's classification. This is inquiry, not complaint, and what are the issue and all of those things. All decomposed, right? Not using language model, but using clear decomposition. You can run an adversarial. You can check what's going on, and I think I did in one example here. I'll pick one example. I think I'll show you similar things in here. Example is doing this, right? Visualizing, we want to say, I'm outraged, my overdraft fee is unfair, I demand refund, right? And in that, when retrieving knowledge graph, it found, okay, here's are the related information. And why this can be a UDAP problem, right? So you can, if you want, you can visualize it, but it's all recorded, every single step recorded. So you know exactly that this complaint is processed. This is what we found. It's an evidence. Okay, draft traversal. If we compare using dense retrieval, you're going to miss because in here it has escalation, right? So in the process, it's unfair. It get UDAP has severity is high. Let me enlarge a little bit on this. It has UDAP problem. Move this one. UDAP, the severity is high, so we need to escalate. This is the example of multi-hopping, right? It touched UDAP because it has fee, it has unfair, it has UDAP, overdraft, it has UDAP. Once it has UDAP, the severity is high. Because the severity is high, it gets escalated, right? So that's the process that is run through the knowledge graph that we talked about before. If you do dense retrieval, hey, is this need to is this concern about regulation and need to get escalated. You can do it with your rack system, but it's going to miss because your rack system based on that memory it miss the escalation process. Okay. So that's why when you have multi-hopping system that need to do decision based on process, based on step, based on several multiple fact, you need to have system that can do multi-hopping. So it's an example of running through checking through PII, extraction, and then aggregation of all cases and all of those. And so every step is run and it check, it measure. So that's basically what you want to do in governance system. You don't just run it and let it for language model to do, but you chunk it into small step process, and every step it will we're going to have the input schema, output schema, the process we record it, the decision we record it, the verifier we record it. So we don't we record what the tool output is, but we record also the verifier. Let's go back to the presentation. Then we're going to dive into something a little bit more detail later. I just want to make sure that I can cover everything. So in the book that you have, I'm going to cover this relatively quickly, but in the book and tell you the step that you can do. The model will be wrapped. Okay, the model will be wrapped. Every tool will be wrapped so that we know what's the input, what is the output, what all the schema, and the execution, and all of those things. Right. So every single step will be checked on the input, output, and the process. You have to loop because you remember you have multiple step that will that's all the tool will be registered. So that's why we can intervene every tool and we can check, we can test every tool. The reasoning will be recorded, will be checked against, and the claim L will be checked. Right, we check with the not only the claim of the model, because if you ask language model to reason, it will give you reason. It may have nothing to do with the language model does, but it will give explanation. You don't trust that. You trust with independent checker. The independent checker evidence is the one that you record. We talk about the 5 tool. I'm going to go through this relatively quickly so that we can go to a little bit more detail. Get set. We talk about checking, verifying, and yes or no, and how close, and all of those things. Right? Those are the role of GMS that we're going to do. That we're using. So we're going to go through a little bit example on that workflow. That's the workflow that you have, and you check the workflow execution. I probably can go to. Let's work on this quickly, and then we go through example. Working memory. This is the GMS, the small memory that we talk about. The trajectory evaluation, because trajectory we not only measuring input and output in agent, we have to measure every single step. Where is the model wrong? How is the model executed properly? So the orchestration need to be checked. The trajectory need to be evaluated, and every step will be controlled, and then we test it. Let me go to an example that make it more real. If you have access, once you register, you have access, you have the very detailed 15 things on the capstone. This is the supplement one is classification. What is the process? How we do that? I'm going to do the harness kits because we talk about Let's do the harness kit first. Where is the harness kit? Let me see. Okay, here is the harness kit because we want to check every single step. Remember the step process, checking it has regex, it has policy injection, uh, prohibited, and all of those things. So that will be checked, every single one of them, right? And then you have the tool. You will be checked using the knowledge graph. It's the policy gate. Hey, is there any injections? We can check what's going on. The PI gate will be checked, so we know that is the plausibility because we do the start, classify complaint, extract, search policy, flag regulatory, draft response. So then we're going to check, hey, moving from classify, the score is this, it's allowed, go to the first step. Now you can go to the next step because classify is approved. Classify and all of this allowed. Why is this important to do this? Because your agent can do things if you do it open-ended using language model. Your agent can do many things that's uncontrollable by you. It happened to me all the time. I told them never push my code to GitHub. I am going to push it manually. That's in the prompt. I store it in cloud.md. But once in a while, because it has all some interpretation, some of the sentence that itself generated and stored in memory, it corrupted that, and it still pushed my code to GitHub. At one point in time, I was banned from GitHub because they think I has bots posting all the time, right? So that's what happened. So every step, hey, is this step allowed? This step allowed only after you've successfully executed this first step. So this is what happened. Check. It's start. From start, it's going to draft response because your LLM is going to take a shortcut. It knows and then goes straight to drafting response and send you response, produce response. It's not allowed. You have to follow all the steps. So in this case, from start going to draft response is going to be denied. Cannot do it. You have to do all the previous step. So this is how this is sounds very rudimentary, but it's very important because your language model is going to take a shortcut all the time. If you ask, it's going to jump all the skip several steps. It's going to go to generate the final step. And then when you told them, you say, "Did you do this?" "Oh, I'm sorry, I did not do." So Claude did that to me all the time, right? Because, hey, this is the process that you have to do. And I start doing it, produce something. I say, did you follow this step? He said, oh, I am sorry. I did not do it. Now let me do it. So that's why the, the process of the checking every step is super important so that your language model is not taking shortcut because it takes shortcut and the human in the loop only read the final outcome. When read the final outcome, how do they know that the output is correct or not? So building the harness to have the execution kit that say allowed or not allowed, and that's exactly what you capture in your knowledge graph. What is the step? What's allowed? Because the knowledge graph will tell you you have to do all of this before you do this, right? So that's what you can do with your GMS is to really as the kit to check and to enforce. So that's one example. I'm going to do a couple more example. Which one that will be interesting? Uh, Classify complaint. Maybe let's do that because that's the first thing. Classify complaint. This complaint classification is done instead of asking language model to say, is this complaint or not complaint, which you can do, elaborate from, we can skip, and all of those things, right? I won't do that. Okay. Why not? Just simply use small language model to do as a complaint classification. And this is what I'm going to show you. We're going to use QN34B and train it with the LoRa adapter to do three-way classification. And all of this tool is in the in the Analytics ForgeLoop tool that you can use, including the data generation. So the source is your data. Okay, let's look at this is the process of just building loading a QN in here. And then you can, okay, I was charged. Then do complaint classification, right? It's okay, complaint, or this just inquiry, and all of those. This is your logic, prop logic answer. And one of the things that we do is really training using low rank approximation. This is how we generate the augmented data, because you have the original example. In this case, I have 20 example. Okay, 20 examples. Some of them complain, some of them inquiry, some of them, right? So based on those, it generate, in this case, an example, we're generating 600, 599 additional example. Some we make it some of the complaint clear, some of the complaint ambiguous, some of the complaint misleading, right? So this is through design of experiment processes in the tool. You can enrich the whatever data you have, and build richer variation of complaint, and you have choice and in that, and then you have set of data, and then you train your LoRa. Okay, train using LoRa. Your the in this case a QM. So you can give any text. It will say complaint or no complaint. Okay, so that's what this one does. Okay, uh, you build a complaint classifier instead of simply asking language model. Because the problem when you ask language model, your language model doesn't understand very specific word of how you handle your complaint, what you define as a complaint or not complaint, right? You typically will probably describe it as prompt or context or description, but it can be confusing it can be misinterpretation by language model. So it's a lot more reliable to build your own classifier and call classifier instead of asking language model. Plus, it's more for you that is in model risk management. It's more conceptually sound because you train it with the data that you're building classification, and you can test the classification. Any question on this? I think I am going to run out of time, but let me do one more thing. Flag regulatory. Okay, let's do this one because this is the regulate. This is again. Uh, uh, this is flag regulatory now. So we parse the complaint, and then we checked it with with the with the GMS. Let's see if I have it here. Oh, I don't have it here. You check it. Which regulatory part that the testing flag, and then if it's UDAP, it's become high, and then escalate. All of this answer coming from your geometric memory system that you built at the beginning, right? You ingest, you train, you build your knowledge graph. So now you check it against the knowledge graph. So that's what that's what you do here. So from any for any complaint, you can read it, and then you check what is the process, and okay, this complaint really thanks to UDAP, and because of UDAP is high, and we need to escalate. So it's very, very transparent. Decision is very transparent. You know exactly the logic, right? So you understand the logic. So in terms of conceptual soundness, you don't have problem. And this is also when you have why is the decision such and such? Yeah, the decision is my knowledge graph, and you can trace it. When you of course you can ask language model, give prompt, and ask language model to do, and it will give you answer. But that's what I call it, part of the prompt and pray as well. How do you know that the answer is correct? So Sri gave me time, uh, warned me at the beginning to give 15 minutes for question and answer. Okay. And I would like to use the last 50 minutes for question and answer. I know I'm going this super fast. So if you have any interest in the future, we can run a lot longer workshop so that we can do step by step, execute every step, understand every step, and run using the notebook, exercising. But you can try yourself. Okay, read the book. I gave you the big idea. Read the book, and it's a tutorial book that you and with along with the code, so you can go step by step. Okay.
Cool. Yeah, thank you, Agus. And Agus is coming back in August, so to do part two of this workshop. So we'll hopefully have had time to digest this and all the materials Agus has shared. So I'm going to be posting it on QSkillBridge, including the recording of this video, so you can go back and review the video and also go through the notebooks. That way, I know these are complex topics which needs to be given the time, and you got to read the material and make sure that you understand. But I know there are a lot of people in here who would like to kind of sink their teeth into the code and into the examples. There are a couple of examples in here. So Sharon, I just mentioned that we are going to post everything on QSkillBridge. So just since you're registered, you will get access to all the video and the materials. So a couple of questions came out here, Agus. One is, I think Namdi was asking, what does geode stand for? And can you explain a little bit about geode?
It's a geometric.
Okay, good. And then
Yes, all this thing, why I call it geometric. So this is just some of your curiosity. So if you follow my Saturday Substack, why is geometric? Let me say this. We have a knowledge graph, yeah? And knowledge graph has entities. It has subject, object. It has head and tail. And its head and tail is a position in a certain coordinate system. So you start that by talking about geometry because you have embedding, right? It's the same thing. We do embedding, okay? Embedding the head, embedding the tail. We don't embed the whole thing. We had the head, we embed the tail. Yeah, every head and tail has embedding, so it has coordinate. That's why you saw it in the geodesic example that I showed you before. Let me remind on this one here. Let's see on the demo. This one, where's right here? This one, smaller one that you can see. So you have location in embedding space. I just draw it in 3D here, but it's in high D, right? You can choose how big is the embedding in the tool, okay? So it has location. So it has coordinate system. From coordinate, if I move in this example, for example, if I have Carol and Eve, Carol has spouse of Eve, yeah? So if I rotate, I do operation. The operation can be translation or rotation, right? In the geometric rotation here in this case, yeah? I do a geometric rotation, I get Eve. So I can measure Carol and Eve are really, if I apply Carol with this rotation operation, I will get Eve, okay? So you see it here, why it's a geometric, because it really geometric at work. And then we need to put algebra on top of it so that it can do operation. That's why I do in my Substack, I use geometric algebra. The work is used behind all of this are really geometric algebra to do all this operation. So we can say, hey, is this a spouse of this? Is this consistent with this? Is this trigger trigger reg X? Okay, so those are measured. Everything measured geometric. Okay, so the geo stand for geometric.
Perfect. So there are two questions. I'm going to try and see if I can consolidate both the questions, Agus. One, both of them kind of related to how do we adopt this in practice. One is like, when companies use it alongside RAG for chatbots. And the second question, which is kind of in the same realm, is it going to be expensive compared to that of a RAG-based approach?
It's very cheap. Very you install it. It's free for you. Okay, but you build it. But let me say this one:
I
why
guess like
your
when
rack
I think expensive was in the context of performance-wise.
is
Um,
super fast? It's a matrix operation. Yeah, it's just a as a factor multiply by m your matrix. You get B. Super fast. Yeah, super fast computation. This is a microsecond computation to run this. To do verification, if you run LLM-as-judge, it takes time and it costs you token. This one is a fraction of millisecond, microsecond, to say yes or no, correct or incorrect. Yeah. So computationally is super fast because think about it. How many entities you have and how many metrics that you need to calculate during training. So you have to spend time for training the system, right? Uh, it's all PyTorch. You can look at the source code. It's all PyTorch. You train it, right? Once you train it, PyTorch execution. And since it's not deep learning here, it's just matrix operation. So it's super fast. It's linear algebra. Yeah. So it's way faster than language model for sure. It doesn't cost you token. It's microsecond. And this is the thing, uh, because you have RAG, your RAG system doesn't know how to do multi-hopping. Yeah, for sure. Because what happened in your RAG system is what? You do cosine similarity. Based on the cosine similarity, you retrieve. Once that retrieve, how do you get? In this one is catastrophic failure because customer complaint, yeah, and policy. It doesn't match. Yeah, when you do RAG, it doesn't match. You cannot just use RAG on this one. Yeah, because it won't match. In the you do cosine similarity, you will not find it because customer doesn't talk about RAG, right? So you may be able to find, okay, unfair. Yeah, check, maybe fine. Okay. So you find things. In here, you get exactly the answer. You know what the sequence will be. Okay. And each sequence, each each triplet, this is triplet. Each triplet has provenance. Where is that triplet coming from? Just like your chunk and pray, you chunk it at will. The way you chunk it, many ways you chunk it. I don't chunk it like that because each triplet it has associated with that. So your chunk will correspond then to triplets. Yeah. And then when you retrieve according to the triplet, not top K. Yeah, not top K. You retrieve according to the triplet. You know exact. So when you need to do multi-hopping, you get the context from each triplet. You give it to LLM, it will give you very good answer because it give you pass it to LLM the exact answer. If you top K, some of them are correct answer, some of them are not. And then LLM, you leave it to LLM to choose. I don't. Okay, I don't do prom and pray. That's why I don't do chunk and pray. Okay, I extract exactly context like that. Context that is exactly context that produce the triplet. Then that one is the one that you serve it to LLM to write. Yeah. So I don't do chunk and pray. I do this for that.
Perfect. Yeah. Um,
But
so
you
I think
can. If you still want to use dense embedding for that, go ahead. Do it, and you can marry, you can do the two. Right?
so. It kind of comes to this question, Agus, on how do we, I mean, as a profession, the first line and the second line, um, how do you see them coming together to adopt something like this? Is it, I mean, like the sharing of the responsibilities, or who starts? I mean, the chicken and egg problem, right?
Yeah.
Like
Well,
how do we kind of
it
operationalize
depends.
this? Is the question.
Yeah. If the first line adopted, That's great. That's always very, very good when first line doing it, right? If the second, and then if not, what you do, you're going to use it as your testing approach. You
Hmm.
test it. That's what the subject of Beyond Ship and Pray. That's the next lecture, right,
Yep.
Sri? In,
Yep.
in August, we're going
August
to do
6th.
Ship
Yeah.
and Pray. We're going to use it for testing.
Yeah.
We're going to test this agent that we built here. Yeah. And how good is this agent that we built and which area that is not good. So I use the GMS, I use all of this for testing. Because when you do testing using this, you can do automated testing because you have document, you ingest it, you build it. Okay? Automatically build your knowledge graph, you build the ground truth. And then you automatically generate all the test scenario using the design of experiment techniques in here. Then you just apply it. So you can run testing end to end without human intervention. That's the
Perfect.
second line. That's the subject of next lecture.
Yeah,
Okay.
that's a
Here is
perfect
we are
segue.
building it.
Yeah.
Okay. We are building it using this step by step. It's gated. Key important things. It's governed. It's gated. When you run it, every step is checked. Every check is verified and recorded. And the recording, what we record, not only what output of every step, but also verification of every step. And that you don't trust everything to LLM because we have outside independent testing here using this tool to independently test. With this, you have high confidence. And I showed you before, right? I compare using one big model compared to small model beat it because the harness, you recall, I'm going to bring back this. I'm going to bring back this slide because this slide I went to it really fast, but this is what's important right here. The engineering outside the model is what make the system reliable, not the model itself. We know the model; it is what it is, right? The engineering outside the model. This is what we do. Is what make it you I'm using this on purpose. The model is the smallest part. So I exaggerate a little bit here. And say the model is the smallest part here. The big part is on the your engineering here to make your system reliable so that you don't rely on the fragile human in the loop. Remember this process that we talk about. Human is for escalation, not checking every step or not just checking every on the output. We check every step. Yeah, I show you before in the quickly in the notebook. Just we check every step, and then it will not go past unless it passed that check. Then the human will have useful to be human over the loop and not human in the loop.
Perfect. So I think that's the perfect segue for the session we're going to have in the next session. So Gus, I'm just going to share one screen if you don't mind. I'm going to request
And
share
and
access
you
again.
guys can download the tool. It's free from PyPy. You can pip install and you can test it. You can go step by step. Register to Knowledge so you have access to the GitHub. You can download. You can get the book. Etc.
Yeah, I'm
Okay.
going to create a wiki page on QSkillBridge with the video and the slides and all the links you've given me in one place, Agus. And it'll go
Yeah.
in the email tomorrow to everybody. So they'll have the email with all the links. So it'll all be in one place. That way, when part two comes in, we will be able to pick it up. Just two quick announcements. One is Jacob Kossoff from Bank of America is going to be doing a guest lecture next Thursday. If you are interested in being a part of this community and kind of learning along the way, we've been putting a lot of time and effort to bring in experts like Agus and Jacob to share their immense knowledge as a part of this. The formal course, it's a 12-hour course, and we have gone through the first cohort, and the second cohort is starting Tuesday. This is the last time we're going to make this announcement. We are starting the course on Tuesday. We meet every Tuesday for 3 hours from 11 to 2, and all the sessions are recorded. and all the formalities and some of the concepts people were talking about. Well, what is geode, what is rag? Many a times some of these concepts are new to many of the folks who are in here, so we will give you the grounding on what you need to do. That way you can start building those enterprise stacks within your companies. I know it's a surprise when developers build in stuff and you bring in for validation, and now you are scrambling like, what all do we do? How much do we do? So I think we are trying to provide this common framework so that you can start building upon it. So I put in the link in the chat window, and I hope to see you, many of you in the class. But again, we have Jacob, and then Agus is going to come back in 2 weeks and talk about the testing and the validation framework. So what we are trying to do is providing the theoretical and the foundational aspects through the course on Tuesdays, and on Thursdays we'll have the guest lectures. So if you want to be continue to be involved with the series, please do make a commitment. That way you can support the community and also kind of get these programs going. Again, Agus, thank you so much for your time, and it's fascinating. I'm going to be like spending a bunch of time over my weekend going through the notebooks, and we will have a lot more questions for you next time. And next week we have Jacob. We all know Jacob. You and I, and Jacob, we kind of go a long way. So we will hear from his perspective on what's happening on the Bank of America side of things, and we will reconvene again in the next 2 weeks. Thanks again all for your participation, and we will see you soon online. Take care. Thanks again.
All right. Thank you.